Alright, boys and girls, I'm going to warn you ahead of time. I'm in the middle of a sneezing fit, so I may stop and sneeze like 47,000 times while we are doing this. But this video is to help you understand the standard algorithm for multiplication. Now, standard algorithm sounds like big fancy schmancy words, but if you kind of break it down, standard simply means normal. Algorithm just means procedure. So this is sort of the normal procedure that people have always been using to multiply, even back in the olden days. So this procedure, this strategy has been around a long time. First of all, we need to set the problem up. We cannot multiply going across like this for the standard algorithm. We need to rewrite the problem. And you always want to write the number with the greatest number of digits first on top. So I'm going to write 98, and then I'm going to include my multiplication sign, and then the 4 is going to line up right with the 1's place. And just like we were doing with the other multiplication strategy, 98 times 4 really means 4 groups of 98. So we're going to kind of think about it first as 4 groups of 8, and then we'll think about it as 4 groups of 90. So that's kind of where we're heading. Let's go ahead and let's start with 4 groups of 8. So the first thing I'm going to do is I'm going to take this 4 and I'm going to multiply it by 8. Well, I know that if I kind of break up my parking lots here into my place values, I know that 4 times 8 is 32. But I know that I cannot put 2 digits in one parking spot. So just like with addition, when this issue happens, what we're going to do is we're going to put the 2 down, and we're going to carry the 3 to the very next place value. And I like to put a plus sign and circle the numbers that I carry just so they don't get lost, and I remember to add those on for the next step. So again, our first job was to take 4 and multiply it by the 8. I'm going to go ahead and switch colors for the next step. The next step, I'm going to stick with that number 4, and this time instead of doing 4 groups of 8, I'm going to do 4 groups of 90. But because my answer is going to go into the tens place, I can really just think about it like 4 groups of 9. So I'm going to now do 4 times 9. Well, I know that 4 times 9, if I use my 9's trick, is 36. But then I still need to add those 3 more from the 32 from before. So this would be 36. Plus 3 more is 37, 38, 39. So because this is the end of my problem, I don't have another digit, I can put both numbers down here. I can put the 3 and the 9. And in case you don't believe me that I can do that, I'm going to prove it to you. I'm going to go ahead and fill in a 0 into this hundreds place since I don't have any hundreds here. And when I go back to that last step, if I were to do it the same way I did here where I took my number of 39 and I kept the 9 down here and I moved a 3 to the next place value. That means that my final step, if I go ahead, would be 4 times 0. Well, 4 times 0 is 0, plus 3 more is 3. And that's how that 3 is able to end up here, because I didn't have anything in that hundreds place. So we end up with a final product of 392. So I'm going to try another one. I'm going to move a lot faster on this one. This time we're dealing with 52 times 6, another 2 by 1 digit. So I'm going to start with the 52 and times, and then the 6 is going to line up right here. So my first job, and I'm going to divide up my place value parking lots. I like doing that. I think that it's really, really helpful. So my first job is to take this 6 and multiply it by the 2. Well, 6 times 2 is 12. I can't put both of those digits down here, so I'm going to put the 2 from the 12 down here and carry the 1 to the very next place value column. So now I'm going to go ahead and move to the next step. The next step is I'm going to take that same 6. And this time I'm going to multiply it by the next digit, which is a 5. Well, 6 times 5 is 30. I can't forget to add that 1 over here. So 30 plus 1 is 31. Because there's no other number to carry that 3 to, I can actually put both of those digits down. So I end up with a final answer of 312. So let's go ahead. Now we're going to look at a 3 by 1 digit problem. So again, I have 453, and you'll notice that I'm spacing my numbers apart. I really want to stay organized, and this 1 digit number is going to go right in that ones place, just like that. And I can go ahead and draw my place value parking lot if that helps. So I'm going to go ahead and I am going to, this time, because there's 3 digits, it's actually going to be 3 attacks with this too. The first attack is going to be right here. So 2 times 3 is 6, just a 1 digit number, nothing to carry. I'm now going to go, and now the 2 is going to attack the 5. 2 times 5 is 10. So I'm going to put the 0 here from the 10, and I'm going to carry the 1 directly next door. I do have to carry it up there because there is a number here in this hundreds column. So the 2's gone after the 3, the 2's gone after the 5, now the 2 needs to go after the 4. 2 times 4 is 8, plus 1 more is 9. And I don't have any other numbers to attack, so we get 906 is my final product. Let's try this one. This one's a little bit different because you'll notice that one of my digits is a 0. And as much as 0 is always kind of our favorite numbers to deal with, for some reason in multiplication, kids tend to struggle when there's a 0, and I'll share with you why in a minute. Let me go ahead and grab this. Okay, so the 9 is going to attack each of these digits one by one. So first, the 9 is going to attack the 3. Well, I know that 9 times 3 is 27. Again, 27 is a 2-digit number. I can't put both digits in one parking spot. So the 7 goes down, and the 2 goes directly to the next place value column, right next door. So now, the 9 is going to attack the 0. The biggest mistake that kids make is they'll say 9 times 0 is 9. That is not true. Anything times 0 is 0. So 9 times 0 is 0, plus those 2 more makes 2. Just a single digit. I don't need to carry anything. And last but not least, I have 9 times 8. Now, because this is the last digit, no matter what I get, even if it's more than 1 digit, I can put the whole part of it down. 9 times 8, when I do my finger trick, I end up with 72. So I can put both digits here. Throw my comma in my answer. I get 7,227 as my final product. Let's go ahead. This is as hard as it gets. In my opinion, guys, if you can do a 4 by 1, then you can do a 5 by 1, a 6 by 1, whatever you want. I kind of recommend, I know I always tell you to include those commas. Part of me says leave the comma out when you rewrite the problem. And I say that because sometimes our commas can look like 1s. I'll show you. If I kind of do this, sometimes our comma might look like a 1. And we don't ever want to mistake our symbols for numbers. That's going to mess with us a little bit. So I'm going to go ahead and erase the comma just from the work. I'm not going to erase it from my answer. Now I'm going to kind of draw in my place value parking lot, just as some dotted lines. You don't have to do this on your paper, but it's just really helpful for me when I'm teaching you how to do this. Because we have 4 digits here, that means the 2 is going to attack the 2, then the 2 is going to attack the 1, then the 6, and then the 7 in that order. And make sure we add anything we're carrying. So 2 times 2 is simply 4, just a single digit. Next column, 2 times 1 is 2, just a single digit. Now we're going to go here. 2 times 6, well, that's double 6, which is 12. Again, 12 is 2 digits. We can't put both digits in that parking spot. So we're going to put the 2 down and carry the 1 directly to the next place value. Last but not least, 2 is going to attack the 7. 2 times 7 is 14, plus 1 is 15. Because there's nothing else over here, even though it's a 2-digit number, I can go ahead and just place both digits here. If you don't feel comfortable doing that, add a 0 where there's nothing, and you'll see for yourself it'll turn out to be the same. So my final product is 1, 5, 2, 2, 4. And because this is my final answer, that's where that comma goes in. So we get 15,224. That's all the examples that I had for you. However, I do want to show you one more. Okay, I'm going to show you kind of about as tough as it gets. Let's do 986 times, let's do 4. So this time I'm not going to do the place value parking lots, and I want to show you how important it is to line things up. I want to make sure that when this 4 attacks the 6, which is the first step, that the number we put down is right here in this column. Well, 4 times 6, 4 is double double. So double 6 is 12 and double 12 is 24. So I'm going to put the 4 down right here in this column, and the 2 is going to jump directly next door. A lot of times at this point, kids will actually take that 2 and jump it too far. That 2 just goes over one place value spot. We were in the 1s, it's going to go to the 10s. Now, again, the most common mistake I see is that kids will now skip all the way from 4 times 6, and they'll skip all the way to the 9. Don't forget, this 4 needs to attack each digit one by one. So now we're going to go 4 times 8. Well, 2 times 8 is 16. So double that, we get 32, plus 2 more is 34. So right here, I'm going to put a 4 down, and I'm going to carry my 3 next door. And then, of course, my last step is going to be 4 times 9, which is 36, 37, 38, 39. And since that's the end of my problem, I can put them both down, and I'm going to stick in my comma. Now, one thing you're going to notice, what you never, ever, 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 ever do when you're multiplying, you do not annex zeros. Don't do it, because you don't need to. The only time that you need to annex zeros so far is when you're coasing. I will tell you that you may need to annex zeros later on, far, far down the line when we're dividing, but we don't ever annex zeros when we're multiplying. Good luck with the standard algorithm. I think you're going to do great.